Okay, welcome to Chapter 7. In this chapter, you can see quite a few lessons. We will be working on polynomial equations and factoring. We're going to get started here with lesson 7.1 and polynomials. So let's not waste any time and we will get started. Please note that I am doing some editing on these videos and I am recycling some older videos and using them. So if you hear me make any references in the videos to page numbers, just ignore it and work on the examples. They will be printed in your note-taking handout and everything will be just fine. All right, let's go. So what is a monomial? And then more importantly, polynomial. So to define it, it says a monomial is a number, a variable, or a product of number and one or more variables. Basically, a monomial is our terms in an equation or expression. So when we're talking about the degree of a monomial, it's the sum of the exponents of the variables in the monomial, all right? So the degree of a non-zero constant is 0, and the constant 0 does not have a degree. We'll talk about this more as we lead into it, but these are just the definitions, and you can find this information on page 207 in your student journal. So here's an example, a monomial 10. It's just the term, it's a constant, right? The degree is 0. And I'll get more into explaining that a little bit later. So the monomial 3x, right? It's the product of a number and a variable. The exponent of the variable is 1, therefore the degree of the monomial or term is 1. When you have this, the exponent of a, so we have 1/2, right? It's kind of like the coefficient has a degree of 0, but then a has a degree of 1 and b has a degree of 2. So the total degree of this monomial is 3. Here, negative 1.8 m to the 5th power has a degree of 5. So this is not a monomial because it's the sum of two monomials, not just one. 5 by itself is a monomial. X by itself is a monomial, right? A monomial cannot have the variable in the denominator, so we wouldn't say that. A monomial cannot have a variable exponent, and it cannot have a negative exponent. Okay, so just a couple different things. So the first up is finding the degree of each monomial. So remember, in A, the exponent has, or the variable x has an exponent of 2, therefore the degree is equal to 2, okay? The exponent for B, x is 1 and y is 3, so when you add 1 plus 3 together, you get a degree of 4. For C, you have 3 and 3, so you have a degree for this term or monomial as 6. Notice that I'm using the word term and monomial interchangeably. That's kind of how I want you to see it. For D, this negative 3 can be rewritten. So here's the reason why these numbers have 0 as the degree. It's because we can assume that the exponent is equal to 0 because we don't see the variable. Okay, does that make sense? So yeah, so it has like a implied exponent of 0. And remember, anything raised to the 0 power is equal to 1. So it's like negative 3 times 1. But that's why the exponent of the imaginary variable is 0. I don't know if you can even say that. That's okay. Here we go. So we are going to start the extra practice is on page 207. We're going to find the degree of the monomial. So again, looking at the variable, what is the exponent? 1. Therefore, the degree of this monomial or this term is 1. W, it's a variable with an exponent of 1. 8, is there a variable? No, there is no variable. Therefore, it's assumed to have an exponent of 0. So all constants, all integers, any kind of form of numerical terms or monomials have a degree of 0. So for number 4, A is 1, B is 1, C is 1, the degree is 3. You add all of them together, okay? For 5, 2 plus 1 is 3. I want you to do number 6. Pause the video and do that real quick, and then check your work. Hopefully you said that it is 2 plus 3 plus 1, or 6. For number 7, 1 plus 3, 4, and number 8, 0. I like to cross my zeros even though I didn't cross that one. Okay, here we go. Moving right along. The core concept. Well, we're classifying polynomials. We're talking about polynomials. So what is a polynomial? It's a monomial or a sum of monomials. Each monomial is called a term in the polynomial. So remember, I've kind of already talked about them being terms. Look at this binomial, 5x plus 2. It's like an expression. Here's a trinomial. So binomial means 2 terms. Trinomial means 3 terms. Pretty much anything over that is just simply polynomial. We don't have special names for 4 terms, 5 terms, 6 terms, and whatever. The degree of the polynomial is the greatest degree of its terms. So now you're being having terms or monomials separated by addition, subtraction, things like that. We're not going to be adding the exponents together. We are simply going to look at the degree that has the highest power, and that would be the degree. So this would be a 3rd degree polynomial, right? If I had to classify it. So a polynomial in one variable is in standard form when the exponents decrease from left to right. So one of the things I like to say is it's in descending order of the variable, descending order of the power of the variable. So we start with the cubed, then the squared to the first power, and then obviously, an exponent of 0 right here. So the degree goes down when it's in one variable. Then if there's multiple different variables, a lot of times you'll see mathematicians, it seems to follow a rule of alphabetical order. All right. So when you write a polynomial in standard form, the coefficient of the first term is called the leading coefficient. So here's some things that you might need. I believe this is on page 207. Yeah, it is. So as you're doing some of the next examples, you can always look back to this. So first, you'll rearrange the terms to put them in descending order of the variable so that the exponents decrease by 1, right? Left to right. Then you look at the leading coefficient, which is 2. The degree here of this whole polynomial is 3. And then, and this is the constant term. And if we had to classify it, we just call it a polynomial. All right, so let's keep going. So writing this in standard form, identifying the degree, leading coefficient. So the first term, 15x, has a degree of 1. X cubed, negative x cubed, has a degree of 3. 3 has a degree of 0. So we're going to put them in descending order of the variable, meaning we'll take this x cubed and put it first, but notice that it is, oops. Notice, I gotta get a little mark there. Notice that it is like a negative x cubed. So when we rearrange the term, keep the operation in front of the number because that is actually the sign of the number. So we have negative x cubed plus the 15x plus the 3. The greatest degree is 3, so the degree of the polynomial is 3. The leading coefficient is a negative 1. And to classify it, because there's 1, 2, 3 terms, we would call that a trinomial. Okay. So that's what we're going to do, classifying them. So for A, right, to put it in standard form, well, it's already written in standard form. It's a monomial. There's no other terms to rearrange or put in descending order. The degree is 4. The type is monomial. Here, we can rearrange them, right? This one would move to the first position, this negative x would be second, and then the constant would be last. So 5x squared minus x plus 4 is a second degree trinomial. And we're going to be working with these quite a lot throughout this chapter and next chapter, and pretty much a couple chapters to go. All right, here, put them in descending order of the variable. Q to the fifth first plus 8q is fifth degree binomial because there's two of them. All right, so in working on this problem, it says in exercise 9 through 12, write the polynomial in standard form, identify the degree, leading coefficient of the polynomial, then classify it. So I kind of go through and I like to underline them. So I look at the one with the highest. So this has an exponent of 1, exponent of 2, and then I assume 0. So this would be my first term, this would be my second term, and this would be my third term. So I would have 3x squared, and it's positive, so that's positive, plus x and plus 5. Descending order of the variable. My degree is going to be equal to the highest degree term, which is 2, so a degree of 2. The leading coefficient, I'm going to abbreviate those, is 3. And then I'm going to classify them. There's 1, 2, 3 terms, so we would call this a trinomial. Okay, switch colors. Over here, there's one term, it's a monomial. So I would just simply say that this is standard form, okay? My degree is equal to 1. The leading coefficient is the coefficient of y, or the square root of 5. And then because there's only one term, this is the monomial. Okay. Number 11. So I'm looking at this and there's two terms. One has an exponent of 5, one has an exponent of 8. So the 8 is the highest degree of x. So that would be my first term and my second term. So I have 6x to the 8th plus 3x to the 5th. So when I'm talking about my degree, the degree would be the 8. When I'm talking about the leading coefficient, that would be the 6. And when I have to classify it, it would be a binomial. All right. I would like you to pause the video and do number 12. And so if I have three terms here, 4 has the highest exponent, so that would be the first one when I put it in standard form. Then it goes down to 2, and then, oops, that would get 2, and then 3. So I would have f to the 4th plus f squared minus the 2f. Okay, so the degree would be 4, leading coefficient would be 1, and the last thing is to classify it. Okay. Okay, so we are ready for the vocabulary and concept check. Go ahead and let me know which problem you will be responding to. Please give me complete sentences. And if you have any questions, please leave them in the prompt provided. And I will see you in class tomorrow.